Good morning, everybody, and welcome to this beautiful April spring day. This is what greeted me this morning. It's a beautiful sky. Nice snow in the trees. Crazy weather. We're going to head downstairs for today's lesson. Bear with me while I walk through the house and down the basement. Alrighty, so this is part 4, I believe, in Mr. Neubert's amazing videos. And we'll get set up there. Hopefully that's in the right spot. That'll work. There's the magic screen. I've got some snowshoes back here just in case I need them later. If it keeps snowing like it is. I've got my snowy sweater on. Yeah, it's beautiful April weather. Alright, you're going to need your textbook. Page 1415 today. We're going to talk about graphing motion. Today I'm going to do distance and time graphs. Keep these videos short and sweet, and then you can review the material for the rest of the class today. Get through the video. You can go through the packet that you turned in. You're going to need to have your iPad up and running to motion graphs. Okay, that's this one. Pull up the PDF motion graphs. And your textbook to page 14. Pause it. Right there. Or right there, maybe. I don't know. Right there. All right. If you're ready, let's do it. All right, here we go. On page 14, we're talking about motion. We're talking about distance and time graphs first. If you notice on the y-axis, there's distance. We're looking at page 14 with the girl running there. That's her motion. Distance on the y-axis is in meters. The time is on the x-axis. Time's always on the bottom. And that is in minutes. Okay? And all this is doing is plotting her motion when she is at zero distance away from wherever her starting point is, and the clock starts running, and a device is measuring distance. Actually, I have a GPS watch that measures my distance when I'm running. It'll track that. I could have it plotted too, just like this. So it's simply plotting motion of her as she's running down the course, and it's going to give you the slope of the line is what we're looking at. The slope of the line includes the rise and the run. Okay, the rise is how much or how far up or down the distance is going in this case on the y-axis, and the run is horizontal movement of the plot on the time in seconds. Time's always moving to the right. Time, once the clock starts, it's always going to move to the right. Can't go back in time, can't stop time. Okay, so it's plotting her motion at 3 different points. Okay, if you look in the book, it's plotting her one point is at 400 meters and 2 minutes. Okay, you can take those numbers. 400 meters is your rise, and 2 minutes is the run, so 400 divided by 2, 400 over 2, if you look in the book in the little green box, is the motion on day 1, is 200 meters per minute is her pace. That straight line is linear, means she's running at a constant speed. She's not varying all that time at 200 meters per minute. The next section, she's traveled another 400 meters, so now she's 800 meters away from her starting point, and it is 2 more minutes later. Okay, so at 800 intersects 4 minutes. You could take 800 divided by 4. You could take another 200 divided by 2 minutes, and you're still going to have 200 meters per minute. And there's Nemo again is joining us again for the lesson today. The next point is at 6 and 1200, 6 minutes and 1200 meters. It's increased from the last point by, once again, 400 meters and 2 minutes. And you can divide that and you get 200 meters per minute. You can take the entire trip of 1200 meters divided by 6 minutes and get 200 meters per minute. So she is a constant speed, okay? The distance is increasing, 400 meters every 2 minutes for the entire 6-minute run. And beyond that, the line extends in a straight line. So it's a linear relationship. She's moving away from starting point at a constant speed. Okay? And the next page, motion on day 2. She's changed a little bit. If you notice the first line segment, from 0 to 600 in 4 minutes is a little bit flatter. It's a little more towards horizontal. Okay, that slope tells you that she's not covering as much distance per unit of time, and she isn't. Every point it increases by 150 meters every 1 minute. And you can plot the whole thing, 600 meters from 0 to 600 meters away at 4 minutes. You see that point? 600 divided by 4 gives you 150 meters per 1 minute, or 150 meters per minute. Okay? That's her pace there. So it's a little bit slower than the day before. She's tired. The next line segment is flat. She's at 600 meters at 4 minutes. Find that point. She's 600 meters away from her starting point at 5 minutes. She's 600 meters away at 6 minutes. She's 600 meters away at 7 minutes. She has not moved. She's stationary. She stopped at 600 meters away from her starting point she took a break for 3 minutes. Okay? And then she's rested. Now she picks up the pace. It's a steeper slope. If you notice that third line segment, it's a steeper slope. She is traveling 300 meters in 3 minutes. I'm sorry, 600 meters in 3 minutes. Or every 200 meters in 1 minute, so it comes out to 200 meters per minute. She's traveling as fast as she was the day before. Okay? So it's a steeper slope, means a faster pace. You're covering more distance per unit of time. Okay? All right, let's go to motion graphs. Okay? This does a better job of explaining this in detail. Your motion graphs, some terminology here. I'm sure that's all on the screen. Motion is a change in position measured by distance and time. Speed tells us the rate at which objects move. Velocity tells us speed and direction, remember. And acceleration tells us the rate, speed, or direction changes. And we're not going to be able to deal with direction. Mostly we're talking about the change in speed, just speeding up, slowing down. Okay, distance graphs. Okay, time is always plotted on the x, as I mentioned before. Distance is always on the y-axis. Okay, if an object is not moving, a horizontal line shown on the distance time graph. So whatever these numbers are, the distance is not changing as time moves on from left to right. Okay, let's say this is 2 meters. 2 meters, 2 meters, 2 meters, 2 meters, 2 meters as time is moving, so she's not moved at all, or he has not moved at all, whatever it is. If an object is moving at a constant speed, it means that it's has the same increase. Time is increasing to the right. This is the one that we did, that slope that we had the girl running at a constant speed. So a straight line means a constant speed. Remember, this is a distance and time graph. Speed and time graph we'll get into tomorrow. That'll change the whole perspective. Okay, 2 moving objects. This is the girl that was moving faster and then moving a little bit slower. A steeper line includes a larger distance, so you're covering more distance over time. In other words, higher speed. Both lines are straight, so both are constant. This one means it's a little more towards horizontal. Remember, if it's completely horizontal, the person is stopped, or the object is stopped. So the steeper it is, the more distance you cover per unit of time. Okay? Graphs that show acceleration look different from that show constant. So if you're showing acceleration, the line is going to be curved. Okay? Down in here, the line is more horizontal. Okay? And as you move from left to right, the clock is plotting something here, then it's here, then it's here, then it's here, then it's here. The line becomes steeper. Okay? So moving relatively slowly, a pretty shallow slope, and then the slope become steeper and steeper and steeper as time goes on, so you're increasing in speed. Okay? What they didn't show, and they didn't show a couple of things on this. So this is the review. Fast, steady pace, it's a steeper angle, steeper slope. Steady speed, a little bit slower speed here, completely stopped. It's accelerating here. It's becoming steeper as it goes from left to right. I'm plotting it here and here and here. This one, which I didn't talk about in the lesson, is the object is getting closer. So from here, you're at the starting point of 0, moving away, and the distance is increasing. If you're plotting it here, then here, then here, the distance is going down. So you're getting closer to the starting point at the base. So this would mean that it's moving at a constant speed, but coming back at the starting point, or returning, moving towards. Another one they didn't show, let me show you these here. So you'd be able to identify A, identify B, what was that object doing? I just touched on this one. C, what's D doing? I'm going to skip E for now. And what is F doing? Okay. You should have said that this one is stopped. This one is moving away at a constant speed. This one's moving toward at a constant speed because it's, let's say, 5 meters, then 4 meters, then 3 meters, 2 meters, 1 meter, then it's at the 0 point. The starting point is the base here. So this object is moving toward the bottom. It's not slowing down. A lot of people think that's slowing down. This is speeding up, right? It's going from more horizontal to more vertical. This one shows slowing down. It's more vertical. It's covering a lot of distance in the first second. And in the last seconds, as the time goes on, the line flattens out. Remember, if it's completely horizontal, it's stopped. So the more the line is moved towards horizontal, the slower it is. Until if it's completely horizontal, then it's stopped. Okay? So stopped, moving away at a constant speed, moving toward at a constant speed, accelerating away, decelerating, moving away from starting point, and this one is just moving at a constant speed, moving away, but at a slower speed than B. Okay? And this person also did not start at 0. They started at maybe a meter away from some starting point, some other point. All right? We are almost done. Some review questions here. There we go. Okay. Got some graphs on the screen. Which of the graphs shows that one of the runners started 10 yards farther ahead of the other? Well, let's look at these. You got two different people, two different lines. This person started at 0, this person started at 10, and this is in yards, should be in meters, but it's in yards. One person did start 10 yards farther away. But let's look at the other ones too. These people started at the same point. Which one's moving faster? This one is, okay? This one's a steeper angle, so it's moving faster than this guy. But this question still is which runner started 10 yards farther ahead. This one started at 0. This one started 20 yards ahead. So this one does not fit the problem. And then D, this one they both started at 0. This one moving away faster, this one moving away slower, both constant. So A is the right answer there. Next problem. In which of the following graphs are both runners moving at the same speed? So we're looking for people moving at the same speed. So the lines should be the same slope. Don't have to be together, okay? But the same slope, the same angle. This should be parallel. This one's moving faster than this guy. This one's moving faster than this person. This person's really moving really slow. This person's moving really fast. these two are parallel, okay? They're moving at the same speed. If you ran the numbers, you could calculate this one's moving 10 yards in 4 seconds, and this one has moved 10 yards in 4 seconds, okay? 10 over 4 for both, okay? And then description, the car is stopped. Which car is stopped? Which car is traveling at a constant speed? The speed of the car is decreasing, and the speed of the car is coming back. Okay. Okay, do you know which one is which? Okay. Sometimes it's easier to knock the easy ones out first. So car is stopped would be C. That's the easy one. The car is traveling at a constant speed. Well, we've got two that are traveling at a constant speed, right? Straight line, linear, constant speed. Let's come back to that one. Number 3, the speed of the car is decreasing. You would think that this one is decreasing, but it's not the speed that's decreasing, it's the distance that is going down, okay? It's 5 meters away, 4 meters away, 3 meters, 2 meters, 1 meter away. So the distance, so that's not it. This one, which I touched on briefly, it's a steep angle here. It starts to flatten out as the object is plotted from here to here, from point to point. It's really fast here, really slow here, almost stopped here. Okay? So we're left with the car is coming back. That would be this one. It's 5 meters, 4 meters, 3 meters, 2 meters, 1 meter. It's getting closer to the base, to 0. There's your 0 point down here. So the car is traveling at a constant speed. This one is the best answer for A. 2A is A. Okay. This one is traveling at a constant speed, but it's coming back at you. And that is it for today. Short, sweet lesson. Get out there and enjoy the snow. Make a snowman. Have a snowball fight before it's gone. All right. And tomorrow we'll change everything and really make it confusing for you with speed and distance. We're going to switch it up. So those line graphs that you just learned on distance and time, you're going to have to stop and think that it's speed that's going up and down on the y-axis, not the distance. So until tomorrow, have a good day, stay safe, stay well, and see ya.